Welcome you all for the discussion of problems on Poisson distribution. If P stands for the probability of success, Q stands for the probability of failure, then the probability of X success out of n trials is given by P of X is equal to m power x into e power minus m by x factorial. So this is the formula to find the Poisson distribution. Okay. Now, in this case, the mean and variance both will be equal to this constant m. And we need to recall one more thing, that in general, in the case of discrete probability distribution, mean will be equal to n into p, number of trials, into the probability of success. And one more thing is p plus q will be equal to 1 always. And further, v will be equal to square root of npq. This is the general result that holds for the discrete probability distribution. But as a particular case, in the Poisson distribution, we will be having both mu and v equal to m. So for this particular distribution, this thing holds. But this is the general result. Okay, keeping this thing in mind, let us move on to problems. First problem I'm going to consider is, in a certain factory turning out razor blades, there is a small probability of 1 by 500 for any blade to be defective. So in a factory, 1 by 500 blades are found defective. See, here we have to take this as P. So generally P stands for probability of success. So here, since we are concentrating on defect, or how many blades will be defective, so this itself we have to consider as P. So don't take this as Q. So 1 by 500 is P. Then the blades are supplied in packets of 10. Use Poisson distribution to calculate approximately number of packets containing no defective in a packets of 10. Calculate the probability of no blade is defective or no defectives. Second possibility, one is defective, only one blade is defective, one defective. Third possibility, only two are defective. I had to find this probability in a consignment of 10,000 blades. So that result should be extended to 10,000 blades. 10,000 packets, sorry. This is what we need to determine. Let us analyze the problem. There is a factory which manufactures blades, and the possibility of a blade being defective is 1 by 500. So let us start with the solution. So here P is 1 by 500, so which is approximately 0.002. And they are supplying blades in a packets of 10. That means each packet contains 10 blades. And we need to determine the probability of no blade is defective, one blade is defective, or two blade defective. That should be computed for a consignment of 10,000 packets. First, each packet contains n blades, 10 blades. So you have to take n to be 10. We have, by Poisson distribution, P of x is equal to m power x e power minus m by x factorial. So we need to compute m first, then only I can proceed with P of x. Let us call this as equation 1. Now m equal to mu, which is generally given by np. So each packet that contains 10 blades and possibility of each blade is defective is, the possibility of defective pieces is 0.02. So generally it will be m, that is mean defective is 0.02. So this is the mean defect, average defect. Okay, then so anyway we got m. So now p of x will be 10 power x, oh sorry, m is 0.02, right? So 0.02 whole power x into e power minus 0.02 divided by x factorial. So this is the Poisson distribution per packet. This is per single packet. But we had to compute the probability for a consignment of 10,000 packets. So the same result you can multiply it by 10,000, that's all. So for convenience, let us take f of x to be 10,000 times of p of x. By substituting value for e and simplifying, you can get that finally f of x equal to 9802 into 0.2 whole power x divided by x factorial. With all simplifications, you get finally this one. Simplification in the sense you have to just substitute for e and then simplify it. So you get 9802, I think it should be 0.02 whole power x. Now let us compute the possibility. First one, probability of no defective. No defective. That means number of defective pieces should be equal to 0. That is x equal to 0. You can check that it will be actually f of 0, that will be 9802 into 0.02 whole power 0 by 0 factorial. It will be 9802 only. Then second case, one defective. One defective means you have to take x to be 1. So it is f of 1. So it is 9802 into 0.02. So you can check that it will be 196. Third possibility is two defective. That is x equal to 2. So you get f of 2, which will be, you can check that it will be equal to 2. So this is how the probability with respect to the Poisson distribution is determined for the given problem. Let us consider one more problem, problem number 2. The number of accidents in a year to taxi drivers in a city follows Poisson distribution with mean 3. Number of accidents follows Poisson distribution with mean 3. Out of 1000 taxi drivers, find out of 1000 drivers, taxi drivers actually, find the number of drivers with no accident. Second one, more than 3 accident in an year. More than 3 accidents in an year. Okay, solution. So here given it is directly given that mu, that is mean, equal to 3, which is equal to m. Then by Poisson distribution we have, by Poisson distribution we have p of x equal to m power x e power minus m divided by x factorial. That is actually e power minus 3 exponential first I have written into m power x divided by x factorial. But this is per driver, possibility of per driver getting into accident. Since we need this data for 1000 drivers, we have to multiply the result by 1000. So let f of x to be 1000 into p of x. Okay. Then with the calculation, by putting the value of e and simplifying, you can check that this will be equal to 50 into 3 power x divided by x factorial. Okay. Now let us find the required probability. First probability, no accident. No accident means x equal to 0. So that is, we need to determine f of 0. F of 0, you can check that you get 50. Then second one is x more than 3 accidents. So x greater than or equal to 3. That means we need to determine p of x greater than or equal to 3. So p of 3 plus p of 4 plus p of 5, you can continue that calculation. One thing that makes this calculation easy is we have this result, right? P of x greater than or equal to a is equal to 1 minus p of x strictly less than a. Similarly, if you want to find p of x less than a, then you can write that as 1 minus p of x greater than or equal to a. So using this idea, we can write this as 1 minus p of x strictly less than 3. So it will be 1 minus of p of 0 plus p of 1. You cannot take negative number. So number of accident means it should be greater than or equal to 0. P of 0 plus p of 1 plus p of 2. 1 minus p of 0, right? So p of 0 have this result. You can substitute corresponding values here, and then you can find that. I'll just write the final answer. You can check that this will be equal to 0.35. So this is possibility of x greater than or equal to 3. So number of drivers with more than accidents is, see, this is calculated per one driver, per single driver. Possibility of having more than 3 accident is 0.35 per driver it is. So for 1000 drivers it will be obvious. Just multiply the result by 1000. Thus f of x greater than or equal to 3 will be 35. Okay, sorry, it is 350, not 35, it is 350. You can do like this, or you can directly compute f of x greater than or equal to 3, that will be equal to 1 minus f of x strictly less than 3. This way also you can do. Okay, this completes the second problem. Let us consider one more problem so that the idea of determining probability using Poisson distribution will be clear to you. Problem number 2% of the fuses manufactured by a firm are found to be defective. 2% of fuses are defective. Find the probability that a box containing 200 fuses, find the probability that box containing 200 fuses is contains no defective, contains number one no defective, and point number two, three or more defective. Okay, now let's do solve this solution. Here P, that a probability of fuse be defective is 2 by 100, that is 0.02, and mean number of defectives is given by m equal to, that is mu equal to n into p, which is actually 200. There are 200 pieces, so 200 into 2 by 100. P is 2 by 100, right? So it will be 4. Now by Poisson distribution we have P of x equal to m power x into e power minus m divided by x factorial, or by substituting for m we will get P of x equal to 4 power x into e power minus 4 divided by x factorial. You can simplify this expression to get P of x equal to 0.0183 into 4 power x by x factorial. Now let us compute the probability. First one, the probability of no defective fuse. We are computing this for single box, so no need to multiply any number to this P of x, right? Keeping that in mind, probability of no defective, that is x equal to 0, so you get x equal to 0, that is P of 0 equal to, actually it will be 0.0183 only, because 4 power 0 and 0 factorial both equal to 1. And second one, probability of 3 or more defective pieces, that is we have to take x greater than or equal to 3. Actually I have to compute P of x greater than or equal to 3, which is equal to 1 minus P of x strictly less than 3, that is 1 minus P of 0 minus P of 1 minus P of 2. You can check that this will be equal to 0.7621. So this is about problems on Poisson distribution. So next video let us discuss problems on continuous probability distribution.